So who's leading in the race to have the most compute power in the world right now? Today, we're going to show you a chart that shows Zuckerberg's Meta blowing everyone else out of the water with Tesla at 6th place. But not so fast. Elon Musk responded saying that the chart is not accurate and actually Tesla would be second highest and XAI would be third if measured correctly. We'll also review his other comments about when AI will be smarter than a human and that Tesla has already spent well over $1 billion cumulatively this year. And finally, based on job postings, it looks like Tesla will be building new, first-of-its-kind data centers. Will this be just for its own use, or might it forecast Dojo as a service, starting yet another multi-billion-dollar market? So today we have Hans Nelson joining us, and Hans has his own YouTube channel on Hans C. Nelson. Thank you, Hans.
Thanks for having me, Herbert.
This is right up your alley. I often turn to you talking about AI, compute, FSD, bots. And so this one I wanted to get your feedback on because it is a few parts here are confusing, but it's very exciting. So let's start off with this table that was presented by State of AI Report Compute Index. And they're showing the number of H100 GPUs and who has them. And you can see here that Meta, which is formerly Facebook, they have 350,000 H100 GPUs. And, they're 10 times more than Lambda or Google, companies like Inflection, Oracle. Tesla is number 6. And it looked like so low compared to everyone else. That's the first thing. Now, this guy says total Zuck domination. He's really kind of owned this space. But Elon comes out and says this is not accurate. Tesla would be second highest, and X and XAI would be third if measured correctly. Do you think he's talking about compute in general, or is it H100? Like, is he basically saying that Dojo would get them up to that level of, closer to second, more than this one?
It's really hard to say, honestly. If you look down at the notes, it does say that those are the figures that are just based on public company filings. And
Mhm.
it does say H100s specifically there. It says that, what is it, Meta on the bottom
Mhm.
has a further 250,000 H100 equivalents worth of
Mhm.
GPU. So I don't know if those are A100s or, what variety of GPUs that those are. And so, obviously, the other thing to take note of here is that H100s are not the only, they're shipping H200s as well and other forms. The new um, NVIDIA GB 100 and 200 are going to be going on sale here shortly. And, I don't know if anyone has gotten an allocation on those yet either. And so, it's kind of a weird way to try and rank who has the most compute, because, the H100 is only one variety of GPU, and it doesn't really give a good sense of, how much cumulative GPU power does any one player have. I mean, the fact that Microsoft and OpenAI aren't on that list is, very curious. Obviously, they have massive supercomputers, and one of the reasons that Google's going to be so far down on that list is because they rely so heavily on their own proprietary TPU. And, no one's going to argue that Google doesn't have massive AI capability, whether it's for training, whether that's for inference, whatever, you want to call it. And so, yeah, I would just say this is a chart that needs to be taken with a grain of salt. And because of that, it is hard to tell, what does Elon mean? I keep hearing unconfirmed rumors through the grapevine that Elon managed to secure very, very large allocations of NVIDIA chips over the past really 12 months. And that's one of the reasons why it's a big reason. They have been deploying Dojo. We do know that. And so it's not that everything that has been deployed over the last 12 months has been NVIDIA, but we do know that NVIDIA has been a big contributor to the fact that Elon says that they're no longer compute constrained these days. Um, and so I would just, put it out there for people to think about. It could be that Dojo is coming along great, and they are able to really rely on that heavily for a number of applications inside of the business. It could be that Dojo's really lagging behind, and they're basically all of the progress that they've made from a supercompute standpoint recently has come at the hands of Nvidia, or it could be somewhere in between. And unfortunately, we don't really have good visibility into which of those three options it really is today. But all of that said, we can just look at the results and we can see how fast FSD is progressing right now. And we know that whatever it is, Elon is correct to say that they're no longer supercompute constrained, and obviously he's throwing his hat in the ring in a major way with XAI too, to try to become a good solid competitor to OpenAI, and you can't do that without lots and lots of compute. So they're probably utilizing anything and everything that they can get from NVIDIA, as well as anything and everything that they can wring out of Dojo, as well as probably anything and everything that they can wring out of AMD and Intel GPUs as well. I think that there's really no limitation, that all these things are production constrained. These are all supply constrained. And so they're probably using whatever they can get their hands on.
Yeah. Okay. So first of all, I think this is a very, very important topic. Whoever has the most compute is going to win the day. And it's actually very reassuring when you hear, number one, when Elon said, what, a couple of weeks ago, 3 weeks ago, he said that we're no longer compute constrained for FSD. When he said, oh, first of all, he is very good friends with Jensen Huang of NVIDIA. Like, Jensen Huang donated the very first H100, N100, I guess, whatever it was, A100s, when OpenAI formed. They're very close. This is 8 years ago in 2016. And so, Elon has predicted what was going to happen with OpenAI and AI in general. He's well ahead of the game. And so it's not like he would not have secured his compute. Clearly, he knows that that's critical.
Yeah. I would be really
Mhm.
curious to know too, because he did say that Tesla would be number two and XAI would be number three on that
Yeah.
list.
Yeah.
The other thing is, we know that NVIDIA is not on that list, and NVIDIA has very, very large deployments of all these things in-house as well. Like, people don't realize that NVIDIA probably has as much compute as any of their customers in-house that they use themselves. So that's one thing. And I don't think that Elon's counting that. And the other question is he counting OpenAI? Is he really saying that Tesla has the second most compute and that Meta has the first? I don't think so. So I think it
Sure.
really is, but
Yeah.
even if
It
not, it's up
if
there
not,
close. Like,
yeah.
it's
Yeah.
huge, it's massive. I mean, even to be anywhere in the ballpark of 350,000 H100s worth of compute is insane. So if he's even at half that, and all of their compute is focused, because for Meta, they're providing a lot of consumer directed services with that. And the same, Microsoft is going to be the same way. Google's going to be the same way. Almost all of these companies, if they have a supercompute cluster that's that large, most of the cycles that are taken up by all of that are going to be allocated to consumer apps. Whereas Tesla,
Mhm.
that is allocated to hardcore machine
Mhm.
learning
Mhm.
workloads that are in the development of intelligence. And it's just kind of a little bit different application. And so even if they don't have as much, they're probably
Right.
not going to get they're probably going to get more bang for their buck. They're probably going to get more
Yeah.
actual AI progress
Yeah.
out of, however, one third, one half of the size of supercomputer that any of these competitors are going to have. And I mean, just watch FSD.
Yeah. Yeah. Okay.
Yeah, just
So
watch
let's
FSD and the progress.
yeah. Yeah.
And
Let's take a look at
I
that.
mean,
Yeah, next. It's big. I mean, so then we're going to show how he's actually said we spent $10 billion in AI. Well, you'll explain exactly what he meant by that this year. So this is it's reassuring. to hear Tesla Elon's himself saying, "Hey, it's not as bad as everybody is saying it is." So let's take a look at this. This is James Dalma, very well-known machine learning expert, real expert in Tesla and Tesla's AI, and he was talking about robotaxi and FSD, and he said of the pieces needed to get to robotaxi, because there was this debate whether it's going to be regulatory approvals is now the biggest critical step, or is it the technology? And of course, Elon and James said it's the technology. The fleet is the most important part. No significant component will be left out because it's enormously valuable and difficult to substitute resource. And I think he's referring to the fleet being obviously the 6 million Tesla cars that are out there. They have inference computers also. And the fact that you have the fleet already out there is obviously a big leg up for robotaxi. So Elon said, pretty much, it has been staggeringly difficult to make generalized self-driving work, requiring all that you describe above and more. The investment in training compute, gigantic data pipelines, and vast video storage will be well over $10 billion cumulatively this year. So if anybody thinks that they're going to just catch up to Tesla, Tesla spent $10 billion in training compute, data pipelines, and video storage. Video storage, and we'll show today that they're actually building more data warehouses. Maybe it's for their video storage, but that is nothing compared to the $250 billion in cars on the road with Tesla designed AI inference computers being trained by the drivers. Can you explain this comment?
Yeah. So, I mean, every car that Tesla has shipped since they started shipping hardware 3 back in whatever that was, 2019, I think, has a one of the most capable inference computers on the planet. And a lot of people think that hardware 3 from a compute standpoint is not going to be up to the task of full self-driving or robo taxis. And this is a great point that James Dalma actually made in a conversation that we had. If anyone's interested in watching it, it's over on Farzad's channel between James Dalma and myself and Farzad. But he was making the point that there are 3 main chips on the hardware 3 computer. You've got some CPUs, you've got some GPUs, and then you have neural net processing units or NNPUs. And the GPUs are about 100 times faster than the CPUs because they can run these parallelized workloads. And so they're running more things kind of at the same time that are not necessarily dependent on one another. The CPU is a very linear process. And so everything that you do, the next step kind of depends on what you did in the last step. And so it really slows you down. And then NNPUs really take things to the next level from the standpoint of being able to parallelize a workload, and they can run 100 times faster when you really take full advantage of them than a GPU on an AI problem, where you've really taken a lot of the complexity of a software algorithm out of it, and you are just hardcore crunching matrix math. And that is what these AI neural nets do, is that it's just huge, huge, huge arrays of numbers that are multiplied, added, divided, transformed. And so you're just doing basic arithmetic, but at a scale that is, unfathomably large. And the version of FSD that we had until recently, where we had hundreds of thousands of lines of C code, that was all running on those CPUs that are 10,000 times slower than these NNPs. And now that we have full end-to-end inference in the vehicle, that means that we've moved the complexity of the software problem that we're trying to solve from these slow CPUs into the fast NNP. And there's going to be some stuff that's still in the GPUs as well, but we've moved the heavy lifting from our slowest component to our fastest component, and we've got a lot more headroom left to go there, actually. And so from a computer standpoint, hardware 3 has a lot of capability that's left that's untapped, and that capability can be unlocked through better and better software. And we are still very early in our understanding of how to deploy neural net software. And there's just a lot of capability that we have left to unlock on that front. And so that means that these computers, these hardware 3 cars that we now have millions of on the road, are only a fraction as intelligent today as they're going to be. And one of the things that this allows you to do when you connect that computer then to a whole suite of cameras and you deploy them all over the world, now you have a 5 million vehicle roughly search engine that you can perform
Yeah.
search on the real world for the data that you need to plug
Yeah.
into your, send that stuff back to the supercomputer to train your neural net how to drive like a human. You have, you have the vehicles that are in place to capture the video, but not only do you have the vehicles to where you can watch other drivers and all the things that they're doing, you also have a human driver that's piloting that vehicle that then is basically teaching or has the capability to teach the neural net how to drive like a good human driver or
Oh,
like a
yeah.
bad, say, hey, this is a bad human driver, please do not do what they do. You can write that type of
Mhm.
logic into it. And so that is, the advantage that Tesla has that still no one else really has. Even, Nvidia is really working to create some good general hardware and software for other auto companies to try and use to develop their own
Mhm.
autonomous driving technology. And they're really using an approach that it they're making it flexible so that they can use whatever sensors they want, including lidar. And if Elon is right and lidar is not necessary, which it sure looks like he's right,
That's yeah.
then that you're making a more complex system than is necessary, and going down a road that is a dead end, and that's going to make other automakers lives more difficult, and it makes Nvidia's life more difficult to develop the hardware and the software that's compatible with all those things in the first place, and then providing these hardware and software packages to companies that really are not technically sophisticated enough to solve this problem, at least not anytime in the near term. So they don't have, there's not enough of these automakers that are committed enough to this path to be installing these hardware and software packages in millions and millions of vehicles so that they can even get this data in the first
Yeah.
place. So it's
Yeah.
more complex, it's more expensive. And because it's more complex and more expensive, it's not in enough cars on the road. That's the very, if it was
Yep.
cheaper, you would see it making more financial sense for a company to be bold. And it really just goes back and shows you how forward thinking and how much insight and forethought Elon had put into this to be putting out cars with these expensive, I mean, it's not that expensive, but it's not cheap either. You've got thousands of dollars worth of computer and camera going into these cars that the software wasn't ready yet. And they weren't, it was all deferred revenue. And sure, they hoped they were going to get there sooner than they did. But they could have sold those cars for much lower
Much
prices. You,
less.
you probably
Yeah.
could have taken $5,000 off the purchase price of the vehicle if you had
Mhm.
decontented those cars. And that
Mhm.
would have, on the one hand, seemed like it would actually be a better thing for the mission. More cars on the road at lower prices earlier on. But
Interesting. Yeah. Yeah.
Elon knew that eventually we're going to solve this problem. And not only did he know, but like people just do not appreciate, like I said earlier, how high quality that hardware 3 computer is and what it's going to be capable of.
Yeah.
And so they knew that they were going to get there, and they had the technical sophistication to make the right computer way earlier. Like even what NVIDIA is offering to people today is, you could probably benchmark it in how many ops per second that they can do, and maybe they'll be close. But as far as the vertical integration and the sophistication, there's not going to be a clean package that is as capable from a compute standpoint and also runs inside of the power envelope that hardware 3 runs on. Like there's not even a better competitor alternative to hardware 3 today, much less hardware 4 that's already shipping, much less hardware 5 that will probably begin shipping in the not too distant future. So, people are just way behind. They're trying to play catch up. And I mean, this is one of the reasons why I have such high confidence in Tesla's very unique ability to
Mhm.
monetize, whether it's FSD, whether it's robo taxis. I mean, Elon seems to be very convinced at this point that they're really moving towards robo taxis. If they can get there, great. I'm going to just kind of base case my hopes for the future on they can make a lot of money just on selling FSD SaaS to consumers. And even that is like a wildly optimistic financial picture for the future. So, obviously,
Yeah.
not financial advice, but no one else is even close to in a position to do the things that Tesla's in a position to.
Yeah. All right. Well, so let's just quickly review. I mean, this is like a huge, huge step, or at least clarification, right? Tesla is spending a lot of money, $10 billion cumulatively this year. He clarified that. Nobody knew that Tesla was spending $10 billion. And he's referring to FSD. I mean, I'm sure he's adding this to all of AI efforts, but $10 billion per year on AI efforts. Then, of course, he explains that that's nothing. That's nothing compared to the $250 billion in cars on the road with Tesla designed AI infrastructures. Everybody seems to forget Tesla has these cars out there. They all have inference chips already, and you've just explained that even hardware 3 and of course hardware 4, they're all very capable and they will be able to do robotaxi. Some people were already concerned that maybe it's old tech, but what you explained was that just the way neural nets worked, that it's a software that was James Dalma and you were explaining. So this is very good news. Tesla has so much money that they're spending, and data warehouses, data pipelines. We talked about video storage. And then blew my mind a little bit when you explained how, yeah, as the cars go by, they're the search engine. They're bringing in videos, but Tesla's able to, really take care of all that and take out the nuggets. Uh, they have a massive real world AI application. No one else has a real world AI application at this point, right? There's all this discussion that, oh, did you hear about Stability AI? They're spending $100 million on data warehouses, but they're only making $2 million per year on revenue. Because how do you monetize ChatGPT? How do you monetize queries, generative AI? It's not yet full, but here's a real world AI that's actually going to make cars uh, autonomous. So he also said, Elon, that reality is far too complex and weird to solve the data problem in simulation. This was a question that many people have. Can't just
Yep.
NVIDIA, who is the leader in simulation, just take in videos on YouTube, then do a bunch of simulation? Of course, simulation helps. And I think some people are saying maybe it takes you 90% there. But that 10%, you need to have, actual physical touch
Yeah.
points. I was talking to the CEO of a robotics company. I'll drop that this weekend, and he was saying that simulation takes you 90% there, but the 10%. Now he said that cars, you might be able to simulate that because the whole point of a car is not to interact with the world, and you don't really need to know like the how heavy the car is on the ground, for example. But a bot simulation won't be able to do it. You need interact with the world, and as you are, that's not something you can just simulate. What is it like to touch a peach, and is it too hard to holding the peach, or when your foot hits the ground on a gravel versus a bouncy material, how does that feel? You can't simulate that.
Yep.
But for Elon to say that reality is too complex and weird to solve the problem in sim, that is yet another reassurance that this is
Well,
not
that's
something that anybody can copy.
that's further explaining why it's so important for them to have the fleet, because the only if sim is not enough, then the only alternative that you have is you have to get the real data. And that's why people want to do sim, is because getting the real data from the real world is hard.
They don't have they
It's
don't they
not
don't have a chance.
possible
Yeah.
unless you have devices that are out there
Mhm.
in the world, and you can't afford to put the devices out there in the real world unless you're selling a consumer product at scale. And that's what most people are not doing, that are especially startups.
No one's done it.
Your
Yeah.
AI doesn't have consumer products in the real world at scale. Neither does OpenAI. Like we're gonna have to see how something like Rabbit AI does, like those and these the humane pins and like
Device.
those types of
Yeah.
things. Apple has consumer devices out in the wild. And they're going to have a lot of capabilities or, potential
Mhm.
if they can structurally right now, both, Google and Apple seem are very concerning to me as far as
Mhm.
their ability to execute.
Yeah.
But both of those companies do have
Mhm.
the pieces in place that if they can pull their heads out of their butt,
Mhm.
they could have
Yeah.
massive futures in this space as well, because you need that real world data for so many things. And I understand where the humanoid robot guy that you're talking to where he's coming from. The physics side of the simulation is way harder for bots than it is for cars. But the physics honestly is not the hardest part about solving full self-driving. It's interactions with other intelligent beings. That's the hard thing, and there you do get
Exactly.
back into
Yeah.
another
Yeah.
area where trying to simulate the variables of how this thing is going to interact with you, or what choices is it gonna make, or where is it gonna go, that is just as hard, if not harder, to simulate than things that are hard to simulate for physics.
Yeah.
And bots are going to
Yeah.
have that problem as well. But that's why you have to have that real data. It's not just, is it physically possible for this collision to occur? It's, what is that thing going to do? I don't know. Or do I? Oh, if I'm actually smart and I can model how whatever that thing is, whether it's a child, whether it's a cat, whether it's a bird, whether it's a human driver, um, or just an inanimate object that's moving in a strange way, we have a complicated enough neural net in our brains to where we can look at something, instantly recognize what it is, and instantly spin up a model of
Mhm.
how it is going to travel.
Mhm. Yeah.
And that is different than just, people think about humans interacting with the real world as like it is a computer simulation. We think, oh, when we're trying to play baseball and we're tracking the trajectory of the flight of the baseball, or the flight of the soccer ball, or that we're doing these complex physics equations kind of subconsciously in our brain, and that's not what it is at
That's not
all.
what's
It
happening.
really does it much more like a neural net would do. Is it's like, I've seen this exact thing before, and I've created a general application, and I can understand, okay, I've seen this, and now I've just internalized that into this complicated neural net system, and I know how to interact with that thing even though I don't really understand how it works.
Yeah. Yeah, this guy that I spoke to, the CEO of a robotics company, he also said there's a reason why I chose robots, not self-driving cars, because self-driving cars is even harder. But it's again another thing where Elon has said that self-driving these cars are baby AGI. And so for me, it's like not only might this solve robotaxi, and it's looking like it's pretty well there, it's heading that way direction. It will help with bots, humanoid bots, an embodied AI, and then it's heading us to AGI as well because it needs to understand, like you were saying, the physics of the world. It needs to understand the context of the world. So okay, let's continue. We've got these comments, we've got investment by Tesla, and now there's even discussions here possibly of data centers. Now, this is just job postings, but oftentimes from a job posting, you can kind of see what it is Tesla's planning to do because they're hiring people to build new, first of its kind data centers. Um, they're hiring staff for it, they're snapping up existing data centers. I don't know about that one. How did they know that they're snapping up some existing data centers?
He
The
goes
data
into that a
center,
little bit later in the article, but
okay.
the point that he's making, so Twitter was using some data centers in Seattle,
Oh, right. Yes.
and
Yeah, that's Twitter. Yeah,
Tesla is now taking over some of
I see.
these old data centers that Twitter was using
Gotcha.
in the past.
Gotcha. Okay. So, as we know, consumer, like you were saying, Amazon, Microsoft, Google, they need to have data centers. So we were explaining that already because they're servicing customers. Tesla's getting into the data center business. So this is a job posting, senior engineering program manager for data center. And it says this role will lead the end-to-end design and engineering of Tesla's first of its kind data centers. So that's interesting. And will be one of the key members of the factory engineering team. That kind of hints that this is not just a regular data center. It's going to be a first of its kind. That's okay, cool.
Well,
How
and
these will be.
people
Mhm.
should key in on factory engineering team. Like
Hmm.
they're thinking of this data center like a factory. And so I don't know how to
Hmm.
interpret that yet, but that is one of those words in there that piques my curiosity.
I just thought that you're going to create a. Hmm. I see you're saying because if you were just creating a data center, you call it a data center. Why would you call it a factory? Like you're creating okay, I don't know. Let's think about that a
And
little bit.
maybe it's a data center, that they're looking to recreate lots and lots of these data centers all over the world, and so maybe that's part of it, that
Yeah,
they're
yeah,
trying to
yeah.
create a copy and paste solution to building these data centers. Yeah, it's fascinating.
I mean, maybe there's a mega pack part of it. It's got to be, right? There's got to be a solar mega pack.
I mean,
Okay.
you would think so, and that's one of the reasons. Let's keep going, and then we can speculate, because at this point we don't have enough information to do anything more than speculate wildly. But it'll be fun to do that.
Fine. All right. And then the other event that happened was Elon was being interviewed on a Twitter, on an X space yesterday. And these are the things he said. AI is the fastest advancing technology I've ever seen of any kind. I've seen a lot of technology. I'm going to go ahead and play the clip and we can listen to him directly.
Talk about. So, love to kick off with AI. Now, what's your take on where we are in the AI race just now?
Wow, that's a long answer. There's so much happening in it. AI is the fastest advancing technology that I've ever seen of any kind, and I've seen a lot of technology. Barely a week goes by without some new announcement. So, and if you look at the amount of AI hardware, the computers coming online that are dedicated to AI, that is increasing what looks like at least by a factor of 10 every year, if not every 6 to 9 months. So when you combine the hardware coming online, really order of magnitude increase every, call it at least every 9 months, and many, many software breakthroughs. If you look at that curve, it looks insane. So I think my guess is that we'll have AI that is smarter than any one human, probably around the end of next year.
AI will be smarter than a human, well, any one human by the end of next year. I think he said by 5 years, right? All humans. But, the growth in AI is so quick. And he said this: the AI compute growth chart says it all. And this is the AI compute growth charts where you can see that computational capacity in trillions on the left. This is the years, I guess 2021. And this is old table, I guess. But you can see how quickly it just skyrocketed. And it's very likely going to keep, I mean, like he said, 10x every 6 to 9 months. We're at an we're we're at a straight line up at this point. So
Yeah.
yeah, what's your thinking about everything you just saw there?
Yeah, it is. One of the other tweets where we saw this recently was just talking about how Moore's Law essentially equates to a 30 times increase over the course of 10 years. And NVIDIA has been delivering a 3,600 times improvement, from that first DGX computer that Jensen delivered to OpenAI that we referenced earlier, to GB, whatever the recent, I think the GB 100 was probably what Elon was referring to, but I'm not sure if that was, it could have just been H100s. That the difference between those two things that were delivered about 10 years apart was 3,600 times. And that, makes Moore's Law look like a snail. And just look at what Moore's Law has delivered to us from a technology standpoint from 1990 until today, so 30 years. We can see more progress than that in the next 10 years because we have that's assuming that the hardware is the bottleneck, and the point that Elon made there was accurate. Our hardware is advancing so rapidly at this point that we're not really keeping up with the capability of the hardware from a software standpoint yet. We are making lots of software advancements, but I would guess that our ability to utilize the hardware is probably going to lag behind our ability to make faster hardware. But even so, we could see technological developments and advancements between now and 2035 that, make the dawn of the internet look like chump change and child's play.
Yep. And then, okay, so you layer all these stories together just today, just to summarize what's happening. Compute, and not only compute, but also the software, as he explained, is 10xing every 6 to 9 months. Tesla is, he says, number 2, number 3. So they're not, regardless of where they are on that list, they are a big player, more than everybody thinks, because they don't know what Tesla's doing. They're buying data warehouses. They're hiring people like crazy, not only for this, but for Dojo. He's explaining that FSD isn't just, that you don't just have the data warehouse. You need the inference computers that are in all those cars. And you got all that video that's coming in, real world application of AI. Tesla's, it's just, you can't ignore this, but people don't realize that this is what's happening. And they're spending $10 billion this year. So people thought that maybe they were just spending 1 or 2 billion. They're spending a lot.
Yeah.
Feeling good about this. And so, yeah, just want to quickly say there that when you see the computational thing going up like that, skyrocketing like that, and then people are still doubting whether or not FSD is going to be solved, whether robots will be able to have useful tasks, whether general AI is going to be, I mean, you're using what you know now or what happened in the last 5 years and not realizing that things change in inflection that helps you make real change in all these things we just mentioned. Next, maybe even 2 years from now, it's going to be completely different already.
Yeah, I mean, the moniker that past performance is not going to be an indication of future results has never been more true than it is going to be right now. And just for the reasons that we're talking about, that we're going to be capable of so many things so much more quickly than people realize. And I think that Elon's comments are connected to their plan to build out data centers, that they realize, one of the things that I believe it was Sam Altman said in the interview with Lex Friedman here recently was that he believes that intelligence is going to be, the core currency of the future. And I think that whether it's NVIDIA computers, whether it's Dojo computers, whatever GPUs and NPUs, supercomputer clusters that they're going to build out, that they're planning to build them out. And the thing that you realize quickly that Elon has mentioned is that power gets to be a constraining factor real quick, that you can't put more than 100,000 of these H100s in a state without bringing down the grid. We talked about this in an episode a couple weeks ago about how the mega packs are super important for this. And so Tesla really does feel like a perfect infrastructure play that, they can they can buy solar panels, or they can make solar panels, and then pair those with their mega packs and whatever else that they need to do to provide these supercomputer clusters, these data centers, with all the clean, cheap, reliable power that they need. But then if you do that, you're going to want to spread them out all over the place. You're not going to want one giant one that serves the whole world. You're going to want them around in different places. And for a couple of reasons. One is it makes building out that infrastructure cheaper. Um, but the other is so that it's closer to where that data is going to get sourced or applied. And so that's one of the things that I'm thinking about, reading that first of its kind data center job posting is
Combined with a
that,
mega pack. Yeah.
yeah,
Countries,
that
each country will have their own, and then it'll
Tesla
be their
could
data wise.
potentially have a roll your
Dojo's a
own,
service.
like fully
Dojo's a
vertically
service. And
integrated. Well,
energy's
and
your
whether it's
service.
Dojo or whether it's NVIDIA, like they could probably make it to where the chips are modular and you can
AI
use
is a
whatever
service,
chips that AI as a service.
and
We'll
energy is a
provide you with
service.
your power
Mhm.
infrastructure. We'll provide you with all of the things around your chips. Obviously, we don't know how well Dojo is going in house. It could be that future versions of Dojo are going to be super competitive with NVIDIA. And so that's definitely a possibility, but it doesn't have to be. That's the thing. It could
No.
be any one of these things,
Yeah.
as long as, because at the end of the day, it's TSMC who's going to be manufacturing the chips. And it doesn't, whether it's Tesla's TSMC chips or AMD's or NVIDIA's or Brock or Cerebras or whoever, there's all of these different players. Um, and we'll probably use all of them and then some. And it's, some of those will go bankrupt, but then other ones will pop up. That these things are going to be, commodities of the future. And there's a whole lot that goes into building out those data centers. And electricity is one of those huge gating factors. And we've been hearing Elon talking about this for so long that of course he's thinking about, okay, if he's thinking about Tesla's own plans, how are we going to solve this problem? And he's creating a solution for it. And if he can create a solution that solves that problem for Tesla, why can't that be something that they actually provide to other people as well?
To the
And if,
world.
if they don't
Yeah.
provide it to other people, then at least we know that they have the ability to solve their own bottlenecks,
Mhm.
and capture a ton of value from that. So yeah, that's a
Yeah.
pretty cool and interesting announcement, from my
Amazon
standpoint.
Didn't Amazon announce that they're building a data center right in right in front of a nuclear power plant
Yep.
because they
Yep.
need power? And so they're now at that point where the data centers are so large that they need to have power, and yeah, so it's going to be in the next 2 years. We're really almost there now.
I
Okay,
know
so this
that
is yeah.
um, Tony Seba is working on a think piece right now that I think we're a little bit past due, but I assume that it's going to have something to do with, he's got his whole concept of superpower. And now we are staring at this massive need for electricity for AI that I think is potentially more than may have been expected. And so he may be reworking his entire energy grid models based on kind of the new amounts of power that we're going to need. And so I've been keeping an eye out for him. I haven't seen that piece drop yet. And when it does, I'm planning to talk to Adam Dorr, who's one of the research directors there with RethinkX and works with Tony, and really get the scoop and the download on how Tony is seeing this whole
Yeah,
thing play out
that'd be
over
cool.
the next decade.
I just want to show this photo. Amazon just bought a 100% nuclear powered data center. This is March. So this is March, April. This is last month. This is Talon Energy. One of the US's largest nuclear power plants will directly power cloud service provider Amazon Web Services' new data center. This is from Talon. They bought this from Talon. This is a real photo. This isn't made up. This is not a Photoshop. This just illustrates again, people are not thinking this through, that this is how
Yeah.
big these data centers are. This is how much energy they take, and they need cheap energy, sustainable energy,
Yep.
not just regular ones, because otherwise it blows out their business model. Okay,
Yep.
we covered so much Hans, thank you so much. Folks, you can see how incredibly talented, intelligent, valuable you are. Appreciate you. Follow him on his YouTube channel, Hans C. Nelson. Thanks, everybody. Bye-bye. I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.